Today we're going to be taking a closer look at the Emlid Reach RX, the RS2 Plus, and the brand new RS3, and we're going to figure out which one of these GNSS receivers you should buy. Now, to fully understand everything about Emlid's GNSS receivers, you're going to want to click on the first link in the description. That'll take you to the Emlid store where all of the technical specifications are highlighted for every single one of these receivers. This video is designed to help you choose which receiver to use for your practical applications. Now, essentially, all three of these devices do the exact same thing. They all utilize satellites to find their positions on Earth, and they all have the ability of doing real-time kinematic or RTK corrections to give us centimeter level accuracy for our positions. So what are the main differences between these three tiers, and which one should you consider for your project? Now, I've covered what RTK is in the past, but very quickly, real-time kinematic corrections uses a process known as trilateration to achieve its corrections. Trilateration uses three segments in coordination with each other in order to achieve corrections to our position. The first is the space segment, which are satellites in the sky projecting their position around the Earth. The second is the control segment. This is a known position on Earth that observes the satellites and projects all of the errors and anomalies associated with the timestamps at which it observes these satellites for others to use to correct their position on Earth. This is done with either a virtual reference system or VRS connected to a continuously operating reference station, or you could set up your own local base station, which is what we're going to do now. Now, we set base stations up over known points. You can use a survey pole, but from experience, setting it up on a tripod is the most accurate way of doing it. Step on all these legs to fix the tripod to the ground. And using a tri-brac, we are able to put our GNSS receiver up top, level up the entire system like we do with our survey poles, and looking through this viewfinder to ensure we are over our known point. I'm going to make sure that we are directly over our point and leveling the bubble to be in the center. Okay, we're looking good. Now I've got my GNSS receiver set up here as a base station, and it's going to observe this known position and give us all of the errors for the coordinates based off of the time at which it observes all of the satellites. Now I'm using the Reach RS2, but you could also use the RS2 Plus or the brand new RS3 as your base station. Now the final segment is the user segment, and that's where we use something known as a rover. Any of the GNSS receivers I showed you can be used as a rover and connect to the base station in order to give us real-time kinematic corrections or RTK positioning. You may have also heard of post-processing kinematic corrections or PPK, and yes, all of these receivers can do that. Now I've made several videos showing how to use base and rover RTK as well as PPK, so be sure to check those out in the playlist above. So you're probably wondering, what about this little guy? Can he do any of this? Before we continue, I wanted to let you guys know that I'm going to be a part of the Academic Hub over at GeoWeek on February 11th through the 13th, 2024. These research projects include utilizing survey techniques using GNSS, remote sensing, AI, geospatial technology, and pushing the boundaries of our industry and pioneering new workflows and technologies for our industry. If you're a student and you'd like to attend GeoWeek, then be sure to use my promo code to get either a free Academic Hub pass, or if you'd like a full conference pass, you can unlock 50% off just for being a university student and one of my subscribers. Check out the link in the description, and I will see all of you in Denver for GeoWeek 2024. Yes, the RX is a GNSS receiver with RTK capabilities, and it does provide very accurate data as you've seen in my previous videos. But what this receiver cannot do is it cannot act as a base station. It doesn't have the capabilities of standing in a static position and logging the data for corrections. It also doesn't have the ability to connect to a local base station like the RS2, RS2 Plus, and the RS3 can. The only way this GNSS receiver works is by using network RTK. So I'm opening up Emlid Flow here, and there is my RX. I'll just load it up. And here I've got the correction inputs, and the only one I have is my N-trip over Bluetooth. Looking in the top right corner, we are now fixed, and we've got the green lights here which tell us we're getting corrections and we're achieving centimeter level accuracy with the RX. Whereas if I were to connect to my Reach RS and go into the input corrections, I have many more options, including the LoRa radio, which is what is used to connect the rover and the base to each other. Now, I don't want to hate on the RX completely. It does have one big benefit, and that is how fast it is at starting up and being ready at collecting data. Let's compare the RX with the RS2 and the RS3. Okay, so I've got Emlid Flow running on my phone. Okay, ready? 3, 2, 1, go. All right, and they're all loading, and I'll check my phone here. I'll just keep refreshing until I can connect to one of them. The RX is available. Amazing, the RX is ready to go. Keep refreshing, keep refreshing. Looks like they're still loading. Again, all of these are connecting through Bluetooth, so I'm keeping this a fair comparison. The RS3 just popped up, and we are just waiting for the RS2 to show up. We're still waiting on the RS2, come on. And there it is, finally. So you can see the RX is much, much faster at starting up in comparison to the RS2 and the RS3. The RS3 is a little bit faster than the RS2, and that's probably because there's a lot more components that are in these two receivers in comparison to this one, but it's nice to have something small like this that powers on very quickly in order to collect data as fast as possible. Another thing to keep in consideration is your internet connection. While I think most people are going to utilize on their phone's internet connection, if you are looking to use a SIM card, this bad boy can't do that. Only the Reach RS2, RS2 Plus, and RS3 have that ability. The Reach RX only has one button, the on and off switch, as well as USB-C charging for its internal battery. Besides that, there is not much else to this GNSS receiver. The RS2 and RS2 Plus have a lot more ports that you can work with. They also have USB-C for charging, a spot for a LoRa antenna for better connection between base and rover, a port to connect external accessories, and the crown jewel, a slot for a nano SIM card. Which brings us to the main difference between the RS2 and the RS2 Plus. The RS2 is only capable of achieving up to 3G connectivity, whereas the RS2 Plus is capable of LTE. Now, Emlid doesn't sell the RS2 anymore because nobody really uses 3G, which is why it was replaced by the RS2 Plus. But essentially both receivers can do the exact same thing, especially if you're using your phone to connect to the internet. So if you have an RS2, there's no need to upgrade to the RS2 Plus. However, there might be reason to upgrade to the RS3. Now the RS3 has all of the same ports and capabilities as the RS2 Plus, but the RS3 has a built-in IMU, giving us the ability to have tilt compensations for all of our observations. Now I recently made a video talking about the Reach RS3's efficiency and accuracy. It definitely did blow me away, and at the price point that it's at, it definitely performs very well while having premium features like tilt compensation. And when we start to take a look at some of the price differences between the RS2 Plus and the RS3, they seem very minimal. A few $100s, you get a really nice brand new GNSS receiver that powers on faster, that has tilt compensation, but in what scenarios is it appropriate? Now I can definitely see this being appropriate for data collection as a rover, since I don't have to worry about plumbing my pole up every time I want to measure a point. But where it doesn't make sense is using an RS3 as a base station. When looking at Emlid's website, we can see that the RS3 and the RS2 Plus have very similar capabilities minus the tilt compensation. So while using your base station and it's sitting still like this, there's no need to have an IMU for tilt compensation. You've already leveled the bubble right here. Therefore, this is standing still. All you have to do is measure up to the bottom of the receiver, get the height of the base station, and an RS2 Plus is plenty to do that. The only consideration you should have for an RS3 is for a rover. The IMU is overkill for a base station, so I just recommend using your RS2 or buying an RS2 Plus and using that as your base station for your rover. If you enjoyed today's video, then be sure to subscribe to the YouTube channel. If you'd like to pick up an Emlid Reach GNSS receiver, then check out the link in the description, and I'll see you guys next time.